Okay, everybody, I thought what I would do is a quick video here with the answers to the GotIt problems, just so you could see it worked out. I've also included the teacher's guide, so you have the opportunity to look at these, but I thought you might like to see them actually solved. So in problem number 1, you have 7x equals 5x plus 4. This whole section is about the idea of solving things where you have variables on both sides. So 7x equals 5x plus 4. Our goal is to get x by itself, but we have x's on both sides. So our first goal is to actually get all of the x's to one side. And I'm going to do that by adding a negative 5x or subtracting a 5x, however you want to look at it, from each side. So I'm going to keep in mind that thing I showed you earlier. Take it down a little more. So I have 7x and I'm adding 5 negative x's. That's 2x equals, these x's just all canceled out. 5x plus negative 5x cancels out. What's left here is 4. Now I'm down to a straight one-step equation. Divide both sides by the coefficient, and I end up with x is equal to 2. And I can check that. I really should get in the habit of always checking my work. So I can check it. I can do 7 times 2. Does that equal 5 times 2 plus 4? Well, 7 times 2 is 14. Does that equal 10 plus 4? You bet it does. On to 1b. And again, if you didn't understand a step and now you say to yourself, oh, I didn't know how to do it, but now I could do it, then pause the video. Don't just listen to me talk. Pause the video, do 1b on your own. So 1b, I have 3x minus 2 equals x. And again, my goal is to always get x by itself, which means I always have to get the x's to one side of the equation. So here I am going to add negative 3x to both sides. Now you might think, oh, I'm going to get rid of the x over here, but then you end up with everything on one side and a 0 over there, and you don't necessarily want a 0 over there. It doesn't really get you to your goal. All right, cancel out. So what's left here is negative 2. Now, what you might have done, some of you might have said, oh, I'm going to make that plus a negative 2. That would be helpful. Then you definitely see that you have a negative 2 left. Here, x plus negative 3x is negative 2x. The last step is to divide by my coefficient, which is negative 2. Negative 2 divided by negative 2 is 1. Negative 2x divided by negative 2 is x. And my answer is x equals 1. Let's check that. Make sure I did it right. 3 times 1 minus 2 equals 1. Well, 3 times 1 is 3, minus 2 equals, and there's crazy pen. Let's get rid of crazy pen, and it does equal 1. There you go. Did it correctly. All right, so now continue on through the examples, and I'll meet you at the next set of GotIt problems. Okay, so in 2a, we have 2 minus 1x plus 3 equals 3.1x minus 2. 2.1x plus 3 equals 3.1x minus 2. There are several ways you could start this problem. You could add a negative 3 to both sides. You could add a positive 2 to both sides. I always like to start by eliminating the x's, and I like to start by getting rid of the smaller numbers. So I'm going to take 2.1x away from each side. When I do that, this cancels out. This side has 3. This side has 3.1x minus 2.1x gives me just 1x. You could write it as just x if you want to. You can write it as 1x. I'm going to change that to addition really quick. And the reason I'm going to do it is it just makes a little more sense for me. You didn't have to do it, but you can. I have negative 2. I'm going to add a positive 2 to cancel it out. I'm going to have 5 here. That's equal to x. And then I really should do my check. Let me bring that up a little bit to give me room to check right here. 2.1 times 5 plus 3 equals 3.1 times 5 minus 2. I'm going to rely on a calculator. 2.1 times 5 equals 10.5 plus 3 equals 3.1 times 5 equals 15.5 minus 2. Well, 10.5 plus 3 is 13.5, and 15.5 minus 2 is 13.5, and I can feel like I did that correctly. All right, scoot out of the way, calculator, because we get to do some fractions. Yay, baby. So I have 1/2 p minus 15 equal to 3/4 p minus 3. I'm going to take away the 1/2 of p. I'm going to take it away here, and I'm going to take it away here. Whenever you're subtracting fractions, everything should have a common denominator. In this case, I know what 3/4 take away a half is. It's 1/4. But I could certainly make everything a common denominator here. 1/2 would be the same as 2/4. So 3/4 take away 2/4. However I decide to do that, I'm going to put the original back just so it's not as confusing looking. I'm going to end up with 1/4 over there. First, let's eliminate this. This just all disappeared, which means the only thing left over here is the negative 15. You're taking away 15, which means it's a negative. If you need to, do that step, change it to an addition problem, do that step here, make it an addition problem. Either way, negative 15. Then I have 3/4 take away 1/2. 1/4 p plus negative 3. I'm going to add a 3 on both sides. When I do that, I have negative 15 plus 3 is negative 12 is equal to 1/4 p. My last step is going to be to multiply by the reciprocal, by 4. Right? Here I'll think of it as 4 over 1. Here I'll think of it as 4. 4 times negative 12, negative 48. 1/4 times 4, remember, everything is commutative here, so those become 1s. I've got everything times 1 times p. I get p for an answer. So I have negative 48 is equal to p. And do I have room to do my check? Maybe right here. Let's see if I can squeeze it in here. Half of negative 48 minus 15 equals 3/4 of negative 48 minus 3. Half of negative 48 is negative 24. If I take away 15 more or add negative 15, that's negative 39. 3/4 of 48. Well, 48 divided by 4 is 12, times 3 is 36. So that's negative 36 minus 3, or plus negative 3, which is also negative 39. All right, I will meet you at the next GotIt problem. All right, welcome to the next GotIt problem. So you can see I wrote down, we call these systems of equations. Systems are any time you're comparing two things, like comparing leases on cars, for example. One lease charges you more to start with but less per mile. The other lease charges you less to start with but more per mile. Which one is the best choice? Or rental cars, a lot of different sorts of things. Back in the day, we used to use we used to use a cell phone as the example. One charges you more per text message, but less per month. But then everybody went to unlimited text messaging, and we couldn't use that anymore. So here we go. We know we have a couple of facts here. We know that for the Redbird, they charge $85 per day plus a one-time fee of $75. Over at King Cruises, they charge $100 per day plus $30. Our goal is to figure out how many days where they will be the same. By the way, when it says write the equation, this is the first part of your answer. The 85 a day plus 75 is equal to 100 a day plus 30, because we want to know when they're the same. So once we have that, we just go through the steps here. One of the nice things about a lot of systems problems is they don't involve any negatives, because you can't have negative days or negative money per day or negative one-time fees. So there are a lot of easy numbers to work with. So step one, get rid of the days here. Cancel that out. That leaves us with 75 here. And over on this side, we had 100. Take away the 85. We're at 15 plus 30. Now we're going to take away the 30. Oh, excuse me. My brain took a little vacation there. We're going to take away the 15. No, gosh darn it. All right, now we are going to take away the 30 from both sides. And when you do 75 take away 30, you get 45 equals 15 days. So finally, we're going to divide by that coefficient. And we end up with 3 is the number of days. So we know if you go on the cruise for 3 days, you will end up with the same price for each. Let's make sure that's true. If you had $85 a day for 3 days plus 75, you would have 85 times 3. You'd be spending $255 for the day part plus 75, $330. On the other side of that equation, if you had $100 a day for 3 days plus 30, you would be spending $300 in daily plus your 30 one time. That would also be $330, and hopefully you had a very nice cruise. All right, there you go. All right, so hopefully that gives you a good start. If you got a little stuck with this, you've got some homework to do, and we will be ready to talk about it next time we see each other. So thanks again for being studious and sticking with this stuff, and I'll see your smiling faces soon.